Welcome to Stein Seal Company. I'm Phil Stein, president of Stein Seal. Since our founding over a half-century ago, Stein Seal has been supplying precision mechanical seal devices to the aerospace, industrial, nuclear, and marine industries. We provide over $30 million worth of seals and related products to these industries. Our seals are designed specifically for the required application, and our engineers use their years of sealing experience, along with their knowledge of fluid dynamics, thermodynamics, materials, and structures to design the ideal seal for your seal application. This has led us to dozens of patent designs. We test those designs in our state-of-the-art dynamic test facility. Manufacturing of our seals can be done at any one of our 3 manufacturing facilities located outside of Philadelphia in the United States, in Merida in Mexico, and in Bangalore in India. The video tour today is of our Pennsylvania facility, which also happens to be our corporate headquarters. We pride ourselves on the dedication and craftsmanship of our employees and the quality of our machinery. After reviewing this presentation, I think you'll see why.
Here at Stein Seal Engineering, we have the Inventor 3D modeling system that we use for modeling our designs. What we have here on the screen is one of our designers showing a 3D model, one of the components that we use and have designed. As you can see, we can model all the geometry for the seals and all of its components. We can break out several sections of it and show the individual components used to make up these assemblies. And we have several examples of the 3D modeling aspects that we use. In addition to our 3D modeling capability, the program itself self-generates the detailed drawings itself that we use for manufacturing. Our engineering department also has the capabilities to do finite element analysis. We have an ANSYS program where we're able to look at what we have here as a typical seal runner. We're analyzing the seal under temperatures and pressures and speeds.
How you doing? I'm Stephen. I've been with the company for 24 years. I'm a CNC milling machinist, as we call ourselves. This is where I work. This is a vertical machining center. We have a Haas rotary table interface into the machine. This is typical of some of the parts we make. This is temporarily called a circumferential seal, one of the very large ones. We work with a large variety of materials: titanium, Inconels, many stainless steels. Carbide is our main choice of tooling that we use to machine these parts.
Hi, I'm Blair Sulak. I'm the Research and Development Test Lab Manager here at Stein Seal. Here in the test lab, we have approximately 20 different test rigs that are used to test aviation seals and industrial seals. Today, I'd like to show you just a few of these test rigs to give you a general idea of what the capabilities are here in the test lab. Rig 21 is an industrial test rig capable of dynamically testing 16-inch diameter circumferential oil seals at conditions that simulate its actual service in the field. This particular rig incorporates a split seal housing design and is operated at approximately 4,000 revolutions per minute. The seal oil inlet temperature is approximately 120 degrees Fahrenheit at a pressure of 75 pounds per square inch. The seal being tested in this rig is used to prevent flammable hydrogen gas from escaping to the environment. Rig 20 is an inner shaft test rig that utilizes 2 simultaneously rotating shafts to simulate the seal's working environment. One of the shafts has the ability to axially translate and rotate either in the same direction or counter direction of its opposing shaft. This rig is used for testing aerospace seals and is gearbox driven to run at speeds approaching 20,000 revolutions per minute depending on the test application. Seal chamber temperatures for this particular test will be approximately 800 degrees Fahrenheit at a pressure of approximately 55 pounds per square inch. Rig 18 is an industrial test rig that is used to test circumferential seals. This rig is gearbox driven and typically operates at speeds of about 3,000 revolutions per minute and maximum air pressures of around 100 pounds per square inch. This test rig is normally run at ambient temperature conditions but can be retrofitted with heat bands or auxiliary heaters to supply additional heat to the test rig if the test requires it. Rig 12 is a test rig that we are currently setting up to dynamically test a face seal for one of our aerospace customers. The test rig will be run in a manner that will duplicate the conditions that the seal will encounter in its actual use. This particular test will be run with an inlet air temperature of 600 degrees Fahrenheit at a pressure of approximately 50 pounds per square inch. The rig is gearbox driven and will be operating at 16,000 revolutions per minute. Here, one of our technicians is working on the setup of the test rig. The test lab incorporates a high-end data acquisition program for each of our test rigs to monitor both the seal environment and the overall mechanical health of the test rig. This software is capable of recording temperatures, pressures, flow rates, and shaft speeds. It's also capable of setting alarms and shutting down the test rig if certain test parameters or rig health parameters are violated.